Let's start with a dream. Suppose that you want to go to the moon today, and you want to go there to build a moon base on the moon. Well, this dream is a bit complicated, if not impossible. Meaning, imagine you want to build a house on Earth. You have to put personnel, tools, materials. Now you want to build it on the moon. So you want to put all of this into a rocket, and you have to send it to the moon. Personnel, materials, tools. Unless you do something completely different, that is 3D printing. You send a 3D printer to the moon, and the 3D printer, using the dust that is already on the moon regolith, will build automatically around itself the moon base. Now, this sounds a bit like a science fiction movie. Well, we did it already. We have already 3D printed a 1.5-ton moon base demonstrator using moon regolith. Actually using a simulant of moon regolith, because when Neil Armstrong went to the moon, he brought back a sample of moon regolith. We duplicated here on Earth, and then we did it, 3D printed. Don't believe it? Well, this is it. It's here. It's real. How did we do it? Well, that's the principle, and here is also the principle of 3D printing. You build objects, three-dimensional objects, in this case, the moon base, by adding material layer by layer, as it's shown here. Now, this is done with moon regolith, but you can do it with any other material you can think of. You start with plastics, metals, ceramics, glass, even human cells. Now that we have a moon base, let's look a bit of the concept. How can this work? Well, we could send there to the moon an inflatable, and then with the 3D printer, we build around this shell. By doing this, that's a very interesting concept, because by doing this, you protect the astronauts from the two main threats they have on the moon's surface, that is, solar radiations and micrometeoroids. Now, let's bring back this concept to Earth. What could we do with this? We want to use a solar oven, so like using the sun, having a lens, and then bake the material. Now, we can do exactly the same on the desert to build houses for people, to protect them. Or after earthquakes or tsunamis, we can protect people building quick shelters and houses just using the resources you have there. Since we are in space, though, let's stay in space. Where else can we print with 3D printing? Well, of course, the obvious idea goes to the International Space Station. As André was saying, we want to build things on the International Space Station. But the first question you should ask yourself is, why? Why should I build on the space station? Well, the answer is here. Apollo 13 mission. They had to come back due to the many troubles they had. They had to come back to Earth, and they were using a part of the spacecraft that was built for 2 people, but they were 3. So they were consuming oxygen much faster than it was designed for. They were saturating the filters, the CO2 filters. So you probably remember in the Apollo 13 movie, there is this guy who says, hey guys, we need to go from this square filter to this cylindrical fitting. And it didn't fit. And they had to do this with the tools and the materials they had on the spacecraft, so extremely difficult. On the spacecraft, they could have simply sent an email there and printed. Well, here it is. This is the Apollo 13 filter, now 3D printed, with the cylindrical fitting they needed and with the shape they needed. This is the true filter. Took us minutes to print it. That's why you need a 3D printer on the space station. And that's why we have now a 3D printer for plastics on the space station. But maybe you want also to have one for metals. Why? Well, because everything can fail. And you don't need to bring all of the materials or all of the possible spare parts that could possibly fail, but maybe will never fail. You just bring a limited amount of powder, and if something fails, then you print it. If it doesn't fail, then you don't print it. Or you can even print tools on demand to do some work that you didn't even think you needed. Funny enough, the story of 3D printing started in ESA 10 years ago with a failure on the space station. Actually, we got this valve. This is a true piece of equipment that was flying on the space station. It's a water valve that keeps the temperature balanced on a side of the space station. It failed. We got a shuttle flight coming down to Earth. We got an astronaut coming to ESTEC, to our laboratories, to ask for a failure investigation, understood what happened. We did the failure investigation, we understood what happened, we fixed the problem. But once we had this valve in our hands, we said, well, wait a minute, this is an ideal case for doing 3D printing. Why is that? Well, it's a very complex design. It starts from a big block of stainless steel. You remove all the material away until you get to this final shape. And then you have to put a weld here. Very complex, very difficult. So we said, this is an ideal case for trying out this 3D printing that at that time for metals was just about to start. So we did it. And we got this. I wish you could have it in your hand. You would go, wow. This is half of the weight. It took us a few hours to manufacture it. This takes days to manufacture. It's done in one piece, so you have no welds, no points of failures. So we said, we won. This is it. Well, no. Because in that time, we did the biggest failure you could do while doing 3D printing, the biggest mistake. That is, we duplicated an existing design. And why did we do that? It's because of this. Because since Stone Age, mankind does exactly this. You start with a big block of stone, you remove material until you get to the final shape, the shape you need. The rest, you throw it away. Now, with 3D printing, we can do this. We can do what Mother Nature does. Mother Nature does two things. It 3D prints, first, because it builds layer by layer. And second, it designs and builds for performances, meaning it puts material where the loads are, like in a tree bent by the wind. The loads of the wind, the pressure of the wind, comes on the bottom. That's why Mother Nature put all the material at the bottom. Mother Nature does not put any material on the top, because there are no loads, so no need for it. We learned our lesson then, and we were able then to go from this is a spacecraft support for the antennas. In all our spacecraft, we have one of these, to this. As you can see, same old kind of manufacturing process, big block, you remove material, you throw everything away. It's so complex that you have to have bolts here. Bolts, as a weld, can fail. Here is done in one piece. Few hours manufacturing time, days manufacturing time. Weight is amazing, is half of it. But yet, the ideal is not yet there. What we needed to do is this. This is what we call the bionic design. This is how Mother Nature would build it, meaning it's putting material where the loads are. On another bionic design, time ago, we were about to test it, and it was so different that the company who built it, not this one, another one, they didn't want to test it. They didn't even want to manufacture it because it felt so strange. They said, no, we are afraid of this. Actually, I remember a colleague of mine saying to me, but this is asymmetric. Well, forget about symmetry. Mother Nature is not symmetric. You are not symmetric. I'm not symmetric. I play squash, and my right arm is much bigger than the left arm. Not just the muscle, the bone. Why is that? It's because Mother Nature, for me, does this. Mother Nature puts a very light structure in the middle of my bone, so what we call the lattice structure, because there I don't need it, there are no loads, and puts a much thicker layer where the red area is, meaning where all the loads for playing squash go. So now, thanks to 3D printing, we can do this. This is a bone on a spacecraft, is a human bone put on a spacecraft. As you can see, here you have a lattice structure, because there are no loads, as in the center of my bone. And here, where the loads are, you have a much thicker layer of material. This is incredibly light, and now we have a human bone on a spacecraft. Though, don't get me wrong, it seems all so easy. It's not easy. We need to qualify the material, we need to qualify the process, we need to standardize, qualify this part, inspect it. But all of this is all happening. It's happening already. We are working on it. The biggest challenge we have with 3D printing is something different. It's this one. Meet my children, Francesco and Marcello. They like to play with toys that are additive. Probably you played as well with this. I did. You add material until you get to the final shape, layer by layer. It's so natural. Then what happens? I went to the university, and I was taught exactly the other way around, that is, removing material. I was a good student at the university, believe me, but I was a disaster to the limit of embarrassment when it goes to technical drawings. Why? Well, because it's completely natural. You have to go from a three-dimensional shape, putting it to a two-dimensional shape, because that's the only way you can manufacture it. Well, now, my children, your children, have a technology that can enable two things. First, they can keep thinking additive, and second, they can design bionic. But we need to teach them. That's the biggest challenge. Now, if you do that, there are no limits. You can even print organs, cells, blood, bones, and this is happening already. This is a prototype kidney. It's printed with stem cells, and the amazing thing is that it's printed to the design of yours, but second is that it knows that is a kidney. So it does what the kidney does. That is, it filters water, separates toxin, and produces waste. If you think this into a space mission, then you can really enable long-term missions like going to Mars, where you can guarantee sustainable life for the astronauts, telemedicine. Now, I have two main messages for you today about 3D printing. The first message is, I'm a believer. I believe that this is a technology that can enable missions that today are not possible. To the moon, remember the dream of the moon? To longer missions, Mars, but also on Earth. But the second message I have is that the biggest challenge we have to face is we need to change the way we think today. And we need to educate people. Professor Richard Feynman used to say that the Nobel Prize for Physics, so respected opinion, he used to say that in engineering, Mother Nature cannot be fooled. I would add, it shall not be fooled, it shall be imitated. And now we have a technology that can enable this, 3D printing. Thank you.